Hello guys, we'll be doing another network troubleshooting project for connectivity issues. Here is our network. So we have a total of 6 VLANs, VLAN 10 through 60. We have 3 multi-layer switches. Switch 1 has VLAN 60. Switch 0 has VLAN 40 and 50. And switch 2 has VLAN 10, 20, and 30. Now the criteria we'll be having to fulfill is all devices will need to be able to communicate with each other. So let's go ahead and get started with that. So we'll start with VLAN 10, just go in order. So it doesn't matter which PC we choose, so let's choose the one with the first IP address, so the .100. Now let's just make sure the IP is correct, so IP config 192.168.10.100, subnets /24 CIDR, and the gateway is 10.1. VLAN 10, 196, 192.168.10.1. So let's see if we can ping the gateway. 10.1. And we can ping. Now let's go verify if we can ping the other host in this VLAN. PC8. 192.168.10.101. And it's ping. Alright, let's try pinging to VLAN 20. Okay. 192.168.20.100, which is PC7. And there we go. Now let's just try PC6. Ping 192.168.20.101. Now we would expect it to work, but we have to verify this. Okay, now VLAN 30. 192.168.30.100. This one is good as well. Let's do .101. Alright, so far PC9 can communicate to all the hosts in this side of the network, connect to switch number 2. So now let's try ping to VLAN 40 and 50, which is on a different switch. Okay, 192.168.40.100, which is PC0. Okay, so we can ping. Now, what I actually want to do is run tracer, just to see the path that it's taking. So 192.168.40.100. And the reason I'm doing this is because it has to go more than one hop. So it's going from the host to the layer 3 switch, to another layer 3 switch, and then to the device. That's the expectation. So the tracer shows 192.168.10.1, which is the default gateway for that PC, and then 10.0.0.2. Now if we look here on the diagram, that's going to this interface on switch 0. And then 192.168.40.100, which is the PC we're targeting. So we're going from PC9 to the default gateway. And the next hop is this interface from switch 0, 10.0.0.2. And then the switch knows where this IP address is. Right, so let's finish pinging the rest of these to see if they work. So the VLAN 40.101 PC. That one works. Ping 192.168.50.100. Okay, so that can ping. Now, if we were to run tracer to this device, what path do you think it will take? Well, it would take the same path it took to go to VLAN 40, except once it reaches layer 3 switch 0, instead of going to VLAN 40, it would go to VLAN 50. So it's going to go to the default gateway for the first hop. Second hop going to 10.0.0.2 of switch 0, and then switch 0 knows, well, here's 192.168.50.100. So let's see that. Yep. Default gateway, the next hop, and the host. Now ping 192.168.50.101, which is PC3. Alright, and finally, communication from VLAN 10 to VLAN 60. Now, based off this network configuration diagram, switch 2 is connected to switch 0 and also to switch 1. And just based off the look of it, routing would go from the PC to the switch for switch 2. And in order to access VLAN 60, the shortest path would be taking this route using 10.0.2.1 as the next hop. So that's our expectation when trying to ping a device from VLAN 60. So let's try that. 192.168.60.100. Okay, immediately got an error. That was abnormal, because before we were getting request timed out, and then we were receiving a reply from the device. But in this case, we are simply receiving destination host unreachable, a request timeout, and then more destination host unreachable. So that normally indicates there's some sort of issue. So let's see if we can ping to the other device still. 192.168.60.101. Destination host unreachable. So yeah, something's wrong. I'm going to do Control-C to get out of that. Let's see if we can just ping the VLAN 60 gateway. 192.168.60.1. Okay. That one's also having an issue. Let's give it some time just in case. Alright, yeah. No. One thing you can also do is try running tracer to see how far exactly the ICMP request is reaching. So let's try giving that a shot, just as troubleshooting step. It's 192.168.60.100. So this PC is reaching the gateway, and it's stuck on the gateway. This is very valuable information. Request timed out. Yep, it's stuck there. Alright, so we can exit out of this command. Now let's see, can we ping this next hop from the VLAN 10? So because we expect PC9 to go to VLAN 10 gateway, and then the next hop which is 10.0.2.1, and then the host in VLAN 60. So let's see if we can ping that. Ping 10.0.2.1. Okay, so we're not getting destination host unreachable. We're getting request timed out. And it does seem stuck. Right? Let's see, we can ping 10.0.2.2. We should be able to do that. Okay. Now, first step I would do is probably verify that this interface is configured correctly. So let's hover over this G01. Let's go on that switch. Right. Now let's just make sure G01 is configured 10.0.2.1. Enable show IP interface brief. Let's go down. G01 10.0.2.1. Let's just verify this one. Show IP interface brief. This is G02 10.0.2.2. Okay. So we know that's configured correctly. Now why is it not able to communicate to this? Well, in order for the router to be able to reach another interface of the router, there would need to be routing for that IP address. So let's go ahead and check the switches to verify that we have routing enabled. So let's do show IP route. Okay, so we have 1, 2, 3, 4, 5 connected routes and 2 OSPFs. Right. So the 2 connected that we have are 10.0.0.0 subnet, 10.0.2.0 subnet. And we have 3 connected 192.168 subnets, 10, 20, and 30. So that's the VLAN 10, VLAN 20, and VLAN 30. OSPF, we have VLAN 40 and VLAN 50. Well, that's VLAN 40 and 50. Now, why are we still not able to communicate to this? Well, one issue is that we're not getting OSPF from VLAN 60, it seems like. So let's go check to see if OSPF is configured on here. Show IP route. Okay, we're not even seeing OSPF show up on here. So let's do show IP protocol. So OSPF1 is configured. We have the 192.168.0.0 with the wildcard 0.0.255.255. Look here. 10.0.0.0 with a wildcard subnet of 0.0.0.7. So what this is actually saying, let me show you. This translates to 10.0.0.0 slash, it's 29. Yep, that's correct. So slash 29. So what this means is that the IP range, usable IP range, is 10.0.0.1 to 10.0.0.0.6. We have a broadcast IP of 10.0.0.7 and next network address subnet is 10.0.0.8/29. So network address is 10.0.0.0. So these are the only IP addresses that would be available for routing based off what's configured in OSPF. So if we look at the diagram, we have 10.0.0.1, and that falls under this range, right? Then we have 10.0.2. So that's a third octet. 10.0.2. 10.0.1. So we're going to need to route for 10.0.1.x and 10.0.2.x, right? 10.0.1.x, 10.0.2.x. So for route summarization for 10.0.0.x to 10.0.3.x, what we could do is route 10.0.0.0.0. Now, what we could use is a /21 CIDR notation. And what this is going to do is we're going to have 10.0.0.1 to 10.0.0.7.254. Usable IP range. Network address is 10.0.0.0. Broadcast IP 10.0.7.255. Next subnet network address 10.0.8.0/29. Sorry, /21. Now with this route summarization, we're going to be able to get all of those 3 different subnet ranges while not letting another IP address such as 10.0.9 or 10.0.244.34. None of these are going to be able to access it, because only this subnet range will be allowed. So this is a good route summarization that we could use. So let's go ahead and verify. Switch to show IP protocol. And this is using that same incorrectly configured scheme. And the VLAN routing is good. This is able to route to all those VLANs because the last 2 octets are fully wildcarded out. This is switch 0, show IP protocol. Yep, same configuration. Now in theory, what we could do is 10.0.0.2 /16, which would have the subnet mask wildcard of 0.0.255. But just for security reasons, you know, I personally just want to have that more local summarization of the /21 CIDR. So let's actually go ahead and write this out. So what we're going to do is we're going to route OSPF 1, since all these switches are using route OSPF 1. And we're going to do no network 10.0.0.0.0.7 area 0. Now this is going to erase this configuration from the routing protocol of OSPF 1. And then we're going to route this. So 10.0.0.0, and the subnet wildcard mask 0.0.7.255. Now, highly suggest practicing your subnetting, subnet masks, subnet wildcard masks, how many hosts there are in each, subnet, CRDR, notation, everything. This will help troubleshooting and configuring, just being a network engineer overall. Right. So this is what we're going to be copying into all the configurations. So let's go to switch to config T. Now let's just go ahead and copy it, paste. So we pasted it. We see interface G01 was full. Let's down, right? Interface G01 loading, and it's full. All right, let's leave that. Okay, we see this is already loading in full. So let's config T, paste. Let's go to the next one. Config T, paste. No. Okay, there we go. So we see loading full. Let's go ahead and show IP protocol. Show IP protocol. Show IP protocol. So let's go ahead and start on switch 2. So we have the correct route summarization for the 10.0 subnet for internal routing between the switches. Show IP route. And we actually have all of the networks. So we see we have 10.0.0.0, which is directly connected. We have 10.0.1.0, right? So 10.0.1 is this area right here. So that's why it's routed OSPF, because it's not directly connected to this switch. Next, we have a connected route of 10.0.2. So that's good. And then 3 connected 1 and 2 168 subnets, VLAN 10, 20, and 30, and then OSPF 40, 50, and 60, which is finally showing up. And we're seeing that the OSPF route to reach VLAN 60 is 10.0.2.1 using G02 interface. So from switch to G02 interface to get to the next hop of 10.0.2.1, which is this one. We didn't see this before on the routing table. Alright, so far looking good. Let's go ahead and check switch 0. Show IP route. So we do have 3 of the 10.0 subnets that are routed. Connected 10.0.0.0, this side, directly connected. Connected 10.0.1.0, connected. So we expect the unconnected network to be showing up as OSPF, which is 10.0.2. Now if we check OSPF, and we see, yes, 2 different routes. So we can use 10.0.0.1 as the next hop through the G01 interface, or 10.0.1.2, which is this one, using G02 interface. OSPF for VLAN 10, 20, and 30. Which is correct, these are not directly connected to this switch. Connected VLANs 40 and 50, as intended, or expected. And OSPF for VLAN 60, because it's not directly connected. So everything's looking very good so far. But of course we would have to test in the end anyway. So the last switch, show IP route. 3 networks that are routed. We have 10.0.0.0, that is OSPF, because it's not directly connected to the switch. It's right here. we have connected 10.0.1.0, which is this side of that switch. 10.0.2.0 directly connected on this side. OSPF for VLAN 10 through 40. Sorry, 10 through 50 actually. I missed that one. Right? And we can see here actually, VLAN 10 through 30. Let's use G01 as the interface that it needs to use to reach that destination. So as far as routing the switch, we'll use this interface G01 to reach VLAN 10 through 30. And going back, OSPF for VLAN 40 and 50 uses G02 to reach VLAN 40 and 50. Finally, connected VLAN 60. Right. So we're going to verify connectivity to all these devices now. So let's go back to VLAN 10 and PC 9. Here. Okay. So we knew originally we were able to ping VLAN 20, 30, 40, and 50 from this device. So let's just try pinging to VLAN 60 right away. So let's actually do a tracer. 192.168.60.100. We could already see progress. So it's going to its default gateway. Next hop 10.0.2.1 and the host. So this checks out. Let's try it from VLAN 20. Should work. Tracer 192.168.60.100. Looks good. VLAN 30. Tracer. Looks good as well. Now let's do it from VLAN 40 and 50. Now, the route that we expect it to take is for me to go through this side of this entire network. Why? Because the shortest path, and that's what OSPF found, to take this side, this route. So the next hop from the switch should be 10.0.1.2. So let's see if that works. Tracer 192.168.60.100 from VLAN 40, which is the VLAN 40 gateway, 10.0.1.2 as we expected, and then the host. Let's go on to VLAN 50. Tracer 192.168.60.100, and it's taking the same path. So I can go on and keep testing connectivity to each single device, but it looks like we're fully solved. Thank you.